Hi everyone, in this video tutorial we are going to be going over how to identify the parent hydrocarbon in a more complex molecule. So remember that parent hydrocarbon is the longest continuous chain and it must possess the highest priority functional group present. We're going to come back to the second bullet point in a bit here. We're going to look at two examples together, one with a simple hydrocarbon and one with an alcohol. So we're going to look at the first example, and what we'll see here is that this is a more complex molecule with multiple possible chains. But remember, the parent hydrocarbon is the longest continuous chain. So you might start scanning a molecule, and you might even start here, and you might see 1, 2, 3, 4, 5, 6. That's 6 carbons long. But there's actually longer chains present. If you numbered here, we have 1, 2, 3, 4, 5, 6, 7. We have a 7 carbon chain, which means that this 6 carbon chain is not the longest continuous chain. If you numbered in green here, you would see that there's 8 carbons. If you numbered all the way across, there's 9 carbons. And then if you numbered across, and also then going up, you would notice that there is going to be 10 carbons. And so that blue chain is the longest continuous chain. That is the parent hydrocarbon. And accordingly, we use the alkyl prefix dec to symbolize that there are 10 carbons. And along this longest continuous chain, we have some substituents, right? And notice here, coming back to our rules, we have 1, 2, 3, 4, and a locant at 7, right? And regardless of how we number this, we will get the 4, 7 locant set. So numbering this way would give us 4, 7, and numbering in this way would give us 4, 7. So because we have this locant set tie of 4, 7, and 4, 7, we would want to number in the direction that would give the first named substituent the lowest locant. And we have a methyl substituent, a 1-carbon substituent, and an ethyl substituent. And notice how the numbering should actually go like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that we give the ethyl the lowest locant, that first named substituent. So this example here is to show you that it's not necessarily the case that the longest continuous chain is just straight across. You might have to consider that chain bending and multiple different chains that are present, but it is the longest continuous chain that will be the parent hydrocarbon. Now, coming back up to the second bullet point, if it's the case that there are two chains tying for that longest continuous chain, how we then pick the correct parent hydrocarbon, that longest continuous chain, is we go with the chain that then gives us the most substituents, the most branches. That is, again, if two chains tie for the overall longest chains, we default to whichever chain would give us the most substituents, okay? Now, we're going to go over an example here. I've just altered the structure slightly, putting on an alcohol functional group. If you remember back to our video on functional group endings, the alcohol has a higher priority functional group ending than the alkane. And accordingly, remember, keep this in mind, the longest continuous chain must possess the highest priority functional group. So in pink here, we have a 6-carbon chain that possesses the alcohol. Notice how the alcohol has been colored there. We have an 8-carbon chain, but notice how this 8-carbon chain does not encompass the carbon directly bonded to the alcohol. We know that that definitely should not be the parent hydrocarbon. This is still looking okay right now, but if you go a little bit further, we see that there's a chain that is 8 carbons in length, right? 8 carbons in length that does possess the carbon bonded to the alcohol. And lastly, that there's a 10-carbon chain, but remember here, that chain is not possessing the carbon that is directly bonded to the alcohol. And accordingly, that is not our parent hydrocarbon. So again, it's really crucial. The parent hydrocarbon is the longest continuous chain that possesses the highest priority functional group. Most resources will not say that right off the bat when you learn IUPAC nomenclature, and you'll have to adapt to it later. I like to teach that right away so that you're always saying, what is the highest priority functional group? And what is the longest continuous chain that possesses that highest priority functional group? The name of this molecule is 5-methyl-2-propyl-octan-1-all. And the numbering of the chain, remember, first and foremost should be done to give the lowest locant to the highest priority functional group. So we number from left to right as opposed to from right to left, because left to right gives the alcohol, our highest priority functional group, the lowest locant possible. And at the 2 position, we have a 3-carbon chain. So we say propyl. The suffix -il is used to denote an alkyl substituent. And we have a methyl substituent. And those substituents are named in alphabetical order. And then when you have a higher priority functional group than an alkane, it's at the end of the name between kind of this alkyl prefix component and the functional ending that we will provide a locant to denote where our highest priority functional group is on our longest continuous chain. Okay, so just to reiterate that, since the alcohol is the highest priority functional group, it is higher priority than the alkane, we number the chain and identify the parent hydrocarbon, and it must include the carbon bonded to the alcohol group, that OH group. And we have to use a locant to say where on that parent hydrocarbon is our alcohol. And coming back to our first example real quick, if you just had a simple hydrocarbon, you can just find the overall longest continuous chain to figure out the parent hydrocarbon.